It all starts with the fuel being delivered to our plant. After the truck is weighed, the driver is assigned one of the 3 storage boxes in which they unload the material. Each of these storage boxes is equipped with an automatic conveyor that can both store the fuel and pull it towards the plant. After the wood has been unloaded, all this happens automatically. The system recognizes which box is in use and automatically switches to another box, so the boiler can continuously be supplied with wood. The boxes obviously are secured. In case someone enters a box, the system automatically shuts it down. When all boxes are filled, the plant can supply itself for 4 days at full load and without additional truck deliveries. When the wood leaves the box towards the boiler, it is conveyed through a sorting unit. During passage, any metallic impurities present are removed and collected from the wood using a magnet. Afterwards, the wood passes through a sieve, which ensures that pieces that are too large do not proceed into the plant, where they could potentially cause malfunctions. About 16,000 tons of wood are burned per year, which is equivalent to around 800 truckloads. At full load, the plant consumes just under 3 tons of wood per hour. The wood originates from regional collection points with short transport distances. Once the impurities have been removed, the wood is temporarily stored in a buffer tank that the boiler independently supplies itself with fuel from. In the process, a cylinder pushes the wood out of the buffer and into the combustion chamber via a chute. To prevent burning back into the buffer, the conveying equipment directly upstream of the boiler operates following a lock principle. In addition, multi-stage fire extinguishing devices are installed in this area, which automatically inject water in the event of a backfire and thus extinguish the fire. Once the wood has reached the combustion chamber, the combustion process begins. The wood is transported through the chamber lined with refractory bricks from top to bottom via a so-called step gate in which every other step moves back and forth. Along the way, the material is completely burned under controlled addition of combustion air in different zones. At a temperature of 900 degrees Celsius, the flue gases then flow through the steam boiler where they transfer heat to the water, causing it to evaporate. Along the pathway to the filtration plant, the flue gases continue to cool down to 150 degrees Celsius. Due to the various heat recovery systems within the plant, a total of up to 95% of the energy stored in the wood is made usable. The plant runs completely self-sufficiently, but is monitored around the clock by our permanently manned control center. The leftover ash from the burned wood mainly collects at the bottom of the step grate, where it is collected in a container. However, the lighter ash particles are carried along with the flow of the hot flue gas and have to be filtered out before being discharged into the chimney. The flue gases are filtered using a 2-stage process. In the first filter stage, a gravity separator captures the heavy particles. In the subsequent unit, the flue gas passes through a mesh consisting of several hundred tubes whose surfaces the remaining tiny particles adhere. Along with the ash from the first stage, the flue ash is collected in a separate silo. Effectively, this process removes over 99% of the articles from the flue gas. Compared to heating systems in private households, the dust content is 5 times lower, up to 20 times than in older systems. The heat output achieved by burning wood is 10 MW, which would be sufficient to supply more than 1,000 single-family homes. We use a district heating network to supply the US military base in Baumholder with approximately 8,000 people in an area of almost 3 square kilometers. The hot steam flows through a branch network of pipes to heat transfer stations distributed around the site, where it transfers its heat to the heating water for the buildings. The steam cools down, condenses, and then flows back to the heating plant as water to then again be fed to the boilers for heat generation. To keep heat losses as low as possible within the network, the pipelines are vacuum insulated. The use of wood keeps 90% of the heat, saving approximately 15,000 tons of CO2 per year.